Saturn, the sixth planet from the Sun, is known for its magnificent and captivating rings. These iconic rings have fascinated scientists and astronomers for centuries. In this video, we will explore the various theories about how Saturn got its rings and unravel this astronomical mystery. Welcome to the segment on capture theory, where we explore one of the fascinating explanations for the origin of Saturn's rings. According to this theory, it is believed that these iconic rings were formed from the remnants of a moon or comet that ventured too close to the planet. As this celestial object approached Saturn, its gravitational forces exerted immense pressure and tidal forces, tearing it apart into countless pieces. In this section, we will delve deeper into the explanation behind capture theory. According to this theory, a moon or comet that ventured too close to Saturn experienced the strong gravitational pull of the planet. As the moon or comet approached Saturn, its immense gravitational forces began to exert a tremendous tidal pull on the celestial object. This gravitational tug-of-war caused tremendous stress and strain on the moon or comet, ultimately leading to its fragmentation and disintegration. In this section, we will explore how the intense gravitational forces of Saturn played a pivotal role in tearing apart the moon or comet. Saturn's immense mass resulted in a powerful gravitational pull on the celestial object, causing tidal forces that stretched and squeezed it. The tidal forces acting on the moon or comet exceeded the structural integrity of the object, leading to its fragmentation. The massive gravitational pull of Saturn ultimately tore the moon or comet apart into countless smaller pieces. In this section, we will explore how the remnants of the fragmented moon or comet came together to form Saturn's iconic rings. As the moon or comet disintegrated, the resulting debris spread out around Saturn. These fragments, ranging in size from tiny dust grains to larger boulders, began orbiting the planet due to the gravitational forces at play. Over time, collisions between these fragments and gravitational interactions led to their collective organization into a ring-like structure that beautifully encircles Saturn. In this section, let's recap the key points of capture theory. According to this theory, Saturn's rings were formed from the remnants of a moon or comet that ventured too close to the planet. As the moon or comet approached Saturn, its gravitational forces tore it apart due to intense tidal forces. The resulting debris spread out and gradually organized into the spectacular ring system we see today, encircling the magnificent planet Saturn. Welcome to the segment on ring-rain theory. In this theory, we explore the intriguing concept that Saturn's rings were formed from icy particles and dust that were once part of larger moons or moons that strayed too close to the planet. These particles, scattered around Saturn, gradually spiraled inward towards the planet, drawn by its powerful gravitational pull. Over an immense span of time, these particles came together to form the distinctive and mesmerizing rings that encircle Saturn. In this section, we will delve into the explanation behind ring-rain theory. According to this theory, the icy particles and dust that make up Saturn's rings were once part of larger moons or moons that strayed too close to the planet. As these moons experienced the gravitational forces of Saturn, tidal forces began to break them apart. The fragments from these moons scattered around Saturn, forming a vast cloud of tiny particles and dust, which became the building blocks of the rings we observe today. In this section, we will explore how the icy particles and dust from the fragmented moons gradually spiraled inward due to Saturn's gravitational pull. As these particles orbited Saturn, they encountered uneven gravitational forces from the planet. The gravitational pull of Saturn acted as a gentle brake, causing the particles to lose orbital energy over time. This energy loss led to a gradual spiraling inward of the particles, ultimately bringing them closer to Saturn and contributing to the formation of its distinctive rings. In this section, we will discuss the fascinating formation process of Saturn's distinctive rings over time. As the icy particles and dust spiraled inward towards Saturn, they began to accumulate and gather in a concentrated region. Over millions of years, gravitational interactions and collisions between the particles helped shape and define the structure of the rings. The particles gradually settled into a vast, thin, and mesmerizing ring system encircling Saturn, creating the breathtaking and iconic spectacle that we marvel at today. In this section, let's summarize the key points of ring-rain theory. According to this theory, Saturn's rings were formed from icy particles and dust that were once part of larger moons or stray moons that ventured too close to the planet. Over time, these particles gradually spiraled inward due to Saturn's gravitational pull, ultimately coming together to form the distinctive and captivating ring system that encircles the magnificent planet Saturn. Welcome to the segment on moon collision theory. In this theory, we explore the intriguing idea that Saturn's rings were formed from the aftermath of collisions between its own moons. It is postulated that one or more of Saturn's moons collided with each other in the distant past, resulting in a catastrophic event. These collisions shattered the moons into countless fragments, creating a debris disk around the planet. In this section, we will delve into the explanation behind moon collision theory. According to this theory, one or more of Saturn's moons underwent catastrophic collisions with each other. These collisions were incredibly powerful and resulted in the breakup of these moons into numerous smaller fragments. The force of these collisions generated an immense amount of debris, creating a vast disk surrounding Saturn. In this section, we will explore how the debris from the collisions of Saturn's moons spread out to form a vast debris disk around the planet. After the powerful collisions, the shattered pieces of the moons dispersed in all directions. These fragments orbited Saturn, gradually spreading out and forming a disk-like structure. Over time, the gravitational forces between the fragments and interactions with Saturn's gravity helped shape and stabilize the debris disk, laying the groundwork for the formation of Saturn's iconic rings. In this section, we will discuss how the debris spread out and eventually formed the iconic rings we see around Saturn. As the debris disk continued to evolve, the gravitational forces between the particles caused them to gradually spread out and settle into orbit around Saturn. The debris, consisting of a wide range of sizes from tiny particles to larger fragments, began to collectively arrange themselves into a circular band encircling the planet. Over an extensive period of time, collisions and gravitational interactions among the debris particles further refined and shaped the rings into the distinctive and mesmerizing structure we observe today. In this section, let's summarize the key points of moon collision theory. According to this theory, one or more of Saturn's moons underwent massive collisions, resulting in the creation of a debris disk around the planet. Over time, this debris spread out and began to orbit Saturn, ultimately forming the iconic and captivating ring system that encircles the planet. The intricate and beautiful rings we observe today are the remnants of these ancient collisions and the subsequent evolution of the debris over millions of years. Welcome to the segment on Reaccretion Theory. According to this theory, Saturn's rings are believed to have formed from a moon or multiple moons that initially existed in orbit around the planet. However, these moons were later disrupted by powerful tidal forces exerted by Saturn itself. As a result, the moons underwent fragmentation, breaking apart into smaller pieces. Over time, these fragmented materials reaccreted and came together, forming the remarkable and intricate ring system that we observe around Saturn. In this section, we will explore the explanation behind reaccretion theory. According to this theory, Saturn's rings originated from a moon or a group of moons that initially formed in orbit around the planet. These moons likely formed from the collision and accretion of smaller objects in the early stages of the solar system. However, as time passed, the tidal forces exerted by Saturn began to affect these moons. The gravitational pull of Saturn on the closer side of the moon was stronger than the gravitational pull on the farther side. This difference in gravitational force caused the moons to experience tidal forces, eventually leading to their disruption and fragmentation. In this section, we will discuss the fragmentation process that occurred as a result of the disruptive tidal forces. As the moons experienced the powerful tidal forces exerted by Saturn, they were subjected to immense gravitational stresses. These stresses caused the moons to crack and break apart, leading to the fragmentation of their structure. The fragmentation process created countless smaller pieces and debris, ranging in size from tiny particles to larger fragments. This debris, once part of the original moon or moons, became the building blocks for the remarkable ring system that now encircles Saturn. In this section, we will explore the reaccretion process that transformed the fragmented material into the magnificent rings we see around Saturn. After the disruption of the moons and the resulting fragmentation, the smaller pieces of debris began to interact gravitationally with each other. Over time, these fragmented materials started to collide, merge, and gradually reaccrete. The force of gravity played a crucial role in attracting and pulling together the fragmented pieces, allowing them to gradually form a coherent ring structure around Saturn. This reaccretion process involved countless collisions and interactions, ultimately giving rise to the spectacular ring system that has captivated astronomers and enthusiasts alike. In this section, let's summarize the key points of reaccretion theory. According to this theory, Saturn's rings are believed to have formed from a moon or multiple moons that were disrupted by powerful tidal forces. These tidal forces caused the moons to break apart and fragment into smaller pieces. Over time, the fragmented material reaccreted through gravitational interactions and collisions, gradually forming the magnificent ring system that encircles Saturn. The reaccretion process involved the merging and attraction of countless fragments, resulting in the diverse and captivating appearance of the rings we observe today. Welcome to the segment on Roche limit theory. The Roche limit is a critical concept in understanding the formation of Saturn's iconic ring system. It refers to the minimum distance an object can approach another celestial body without being torn apart by the tidal forces generated by that body's gravity. In the case of Saturn, this theory suggests that a moon or a small moon-sized object once ventured within Saturn's Roche limit. The gravitational pull exerted by Saturn was so strong that it caused immense tidal forces to act on the object, ultimately leading to its disintegration and the formation of the magnificent ring system we observe today. In this section, we will explore the concept of the Roche limit and its significance in understanding the formation of Saturn's ring system. The Roche limit is a critical value that represents the minimum distance at which a celestial object can approach another object without being torn apart by tidal forces. It is determined by the competing gravitational forces between the object's own gravity and the gravitational field of the larger body. When an object, such as a moon or a small moon-sized object, ventures within its Roche limit, the tidal forces exerted by the larger object become stronger than the gravitational forces holding the object together. As a result, the object is subjected to powerful tidal forces that cause it to be torn apart or disintegrated. In this section, we will delve into the idea that a moon or a small moon-sized object once entered Saturn's Roche limit, leading to the formation of the ring system. This moon or object would have been in orbit around Saturn, initially maintaining its structure and integrity. However, as it gradually approached the planet and crossed the Roche limit, the tidal forces exerted by Saturn's gravity became dominant. These tidal forces began to pull on the moon or object more strongly on its closest side to Saturn compared to its farther side, causing a tidal bulge or deformation. As the moon or object continued to approach and got closer to the Roche limit, the gravitational forces exceeded the object's structural integrity, causing it to break apart. This process resulted in the creation of countless fragments that spread out along the original orbit, forming the characteristic ring system around Saturn. In this section, we will explore the role of tidal forces in the breakup of the moon or small moon-sized object that entered Saturn's Roche limit. Tidal forces are the result of the gradient in gravitational pull across an object caused by the gravitational field of another body. As the moon or object approached Saturn and crossed the Roche limit, the tidal forces exerted on it became increasingly intense. The gravitational pull on the side of the moon or object facing Saturn was stronger than the pull on its farther side. This differential gravitational force caused significant stretching and deformation of the object, exceeding its internal cohesion and structural strength. Eventually, the tidal forces were strong enough to overcome the object's gravitational self-attraction, leading to its breakup into smaller pieces. These fragmented pieces then dispersed around Saturn, forming the magnificent and distinct rings that we behold today. In this section, we will uncover the process behind the formation of Saturn's iconic ring system as a result of the Roche limit theory. Once the moon or small moon-sized object entered Saturn's Roche limit and broke apart due to tidal forces, the resulting fragments dispersed and spread out along the object's original orbit. These fragments ranged in size from tiny particles to larger chunks. Over time, the gravitational interactions between the fragments caused them to collide, merge, and accrete. The force of gravity acted as a binding agent, pulling the fragmented material together and gradually forming the stunning ring system that encircles Saturn. The rings consist of countless individual particles, suspended in orbit around the planet, creating a mesmerizing and intricate spectacle that continues to captivate scientists and observers alike. In this section, let's summarize the key points of the Roche limit theory. The Roche limit refers to the minimum distance a celestial object can approach another object without being torn apart by tidal forces. In the case of Saturn, this theory suggests that a moon or a small moon-sized object once entered Saturn's Roche limit, leading to its breakup and the subsequent formation of the magnificent ring system we see today. As the object approached Saturn, tidal forces caused by Saturn's gravity stretched and deformed the object until it eventually disintegrated. The fragments resulting from this breakup then spread out along the object's original orbit and gradually reaccreted to form the distinctive rings encircling Saturn. The Roche limit theory provides a fascinating explanation for the origin of Saturn's iconic rings and deepens our understanding of the dynamic processes occurring in our solar system. The origin of Saturn's rings is still a topic of ongoing research and exploration. While scientists have proposed several theories, there is still much to learn and understand about the formation and evolution of these magnificent rings. Studying Saturn's rings provides valuable insights into the dynamics of planetary systems, the formation of moons, and the processes occurring in the early stages of our solar system. As our knowledge and technology advance, we may uncover more answers and unravel the mysteries surrounding Saturn's rings. Join us next time as we continue to unlock the secrets of our universe.